So in the last video, I explained DNS in the best way I could. So today I want to explain another concept, and today we want to talk about TLS. TLS Handshake. We want to talk about TLS Handshake and where does this actually fall in. Now, when you get asked a question like what happens when I type google.com into my browser, usually you talk about a specific process, and it usually goes in. The first process is usually DNS lookup. DNS lookup is usually the first process. Then the second process is usually TCP handshake. TCP handshake. And the third process usually comes to TLS handshake. And then the last one is basically how do you transfer your HTTP request. So when you ask about explain what happens to when you type something into a particular box, so you talk about DNS lookup, TLS handshake, TCP handshake, and then the HTTP request. This should be able to answer that. Now, yesterday we talked about yesterday we talked about this. So yesterday we talked about DNS lookup. You can go check out my video. I'll put it up here. And then TCP handshake. So TCP occurs at the transport layer. So we have TCP and UDP. TCP handshake, I probably should have made that one. I probably will make a video about TCP handshake, and then TLS handshake and HTTP request. So TLS basically occurs because you want to secure your data. So today, let's talk about TLS handshake and what that specifically entails. So let's go. So TLS handshake. TLS handshake. Good. So what is a TLS handshake? So once your TCP connection has already been established, now we want to make sure that your data is secured. So you do DNS lookup until you find your physical IP address. After physical IP address, you now go to what you call TCP handshake. Now TCP handshake basically makes sure to synchronize your two TCP peers, to synchronize them with a sequence number so that a connection can be established. And now after that, after you do what you call the 3 TCP handshake, you have with the TCP handshake we have 3. So if you have, let's say, a client here and a server here, so I'll have to talk about TCP handshake a little bit before I talk about this. So if I have a client and server for TCP, sorry about that, client, and then let's talk about server. And then I want to initiate a TCP handshake. So first thing is we are trying to synchronize. So we send what we call a SYN. We're going to send what we call a SYN synchronization. So this is synchronizing. It's sending the client, this peer and this peer is sending a synchronization. Say, okay, this is my sequence number. And then what happens? The server also communicates back by saying, okay, I have acknowledged your synchronization. So you have acknowledged your synchronization basically. I have acknowledged your synchronization. So SYN and then that, and then SYN acknowledge, and then it has acknowledged, and then this client again does what do you call this? So after acknowledging this synchronization number, it also sends its own synchronization number that it has. So SYN arc, and then after that, your client is going to acknowledge. It's going to acknowledge the server's synchronization number. So after that is done, and then now we can actually start talking. So usually it happens in 1, 2, 3, 4, but because the server acknowledges and then synchronizes, sends its synchronization number, so we put this into 3 different forms. So that is why we call it 3-way handshake. So this arc and SYN is basically done. So it is usually SYN arc, and then acknowledgement. So after this, now we have established a TCP connection. TCP connection is basically what you call connection oriented. So it's good because it makes sure that data is transferred to the correct point. So whether it's going to reinitiate packets when there is a problem with when packets have not gotten, we have what we call we have checksum to make sure that data that was sent is what arrived. So after this, now we need to make sure we want to secure our data, and you guys know about securing data through SSL. So this was basically a TCP handshake in the first place. Let's just change this to a TCP handshake. So now let's talk about TLS handshake. Now let's talk about TLS handshake, which I wanted to talk about today. TLS handshake. So we're good now. So let's go about TLS handshake. So now you have a TCP connection, you want to secure your data. So what do you do? First thing, let's come here and let's create this is going to be our client. I'm going to Control-C, Control-V. So I have, this is a client and this is my server. So now we want to synchronize. So come here and say, let's talk about this being our client, and let's talk about this being our server. So we're good. So now we want to synchronize. So the first step is what we call a client hello. Yeah. So what we have first is a client hello. So basically we call it client hello. So client sends a hello request, and in this particular request, we have some things. So it's basically sending a hello, telling the server that I would like to connect. I would like to specifically connect over a secure network. So what does it do? First thing it sends, in this particular case, it will send number one thing it's going to send here is it's going to send what do you call it, a client random. So a client random is basically just a random number that the client generates. Good. Second thing it's going to send is a TLS version. TLS version supported. So what TLS version does it specifically support? It's going to do about a TLS version that it supports, and then it's going to also send a little bit of cipher suites that it also supports. So this is what you call a client hello. So it's going to say, okay, this is it's going to send, this is the client random number that I just generated, and then you're going to see where the random number is used. Then we have a TLS version. So TLS, it's basically saying I am this particular client, this is the TLS version I support, or this is the minimum TLS version I can communicate over. And then cipher suite. So cipher a bunch of suites that you use to communicate. And then what happens next is the client says, okay, sure. So the client comes in here, basically, and the client comes in here, and the client does what you call the server. The server does its server hello. Okay. So basically the server does its server hello, which basically means what exactly is a server hello. So it's going to do the same thing. So it's going to generate a server random. It's going to and send a server random. So it has a server random. After a server random, what else do we have? After a server random, we have also cipher suites. So it's sending a TLS. Let's talk about TLS version. So this guy already sent the first TLS version. So it's basically sending back and saying, okay, you support this. I'm also able to support the same TLS version that you have. So TLS version, and then it also sends back a whole cipher suites that it uses. So if they find out that the cipher suites they use match, then that's okay, basically. And if they find out that there are some suites that are supported by client not by server, then they probably resolve how they need to communicate. Good. So we've already fixed that. Now after that, the server also sends one more thing. Yeah, the server also sends one more thing. Yeah, so what you call a TLS. So we can use that as second time in this case. We can use that a second time in this case. So basically we'll say the server will also send what you call the SSL certificate. Certificate. Now SSL stands for secure socket layer, and TLS stands for transport layer socket. So you might ask, why is he sending a TLS and not sending an SSL certificate and not TLS? Basically SSL certificate is the general common name. Now SSL used to be an earlier version, but TLS is basically the more recent version, a more secure version. So SSL is just saying SSL basically is just TLS is just SSL but better. Yeah, so when we say SSL certificate, don't be confused. So we sell SSL certificate, and in this SSL certificate we have a public key. So if I come here to public GitHub and I click on this particular place, site settings, no, sorry about that. This is the new icon for locked connection is secure, and then certificate is valid. So it will send its certificate, and usually when it sends a certificate, it has a public key that is attached to that. Yeah, so we have a public key that is attached to that certificate that also comes along with this SSL certificate. Okay, good. Now after that, now the client needs to do something. The client now tries to confirm the validity, and the client needs to now authenticate. So the client needs to authenticate that particular the client basically needs to authenticate. So the client basically tries to authenticate the SSL certificate with what we call a certificate authority. With the certificate authority. So if you come here, like we just said, sorry again, you come here to site settings. No, it just says, why am I going to site settings? You come here to connection is secure, and then you click on certificate is valid. We have issued by. Yeah. So what is issued? So we have a certificate authority. Yeah. So a certificate authority is basically a middleman that most people trust. Now you can sign your own certificates, but most people don't trust you. But if you have a common certificate authority that people trust, we are going to use them to actually try authenticate. So that case, that is the certificate authority. So the client is going to try to authenticate that SSL certificate using basically the certificate authority. Yes. And and then one of those methods of its trying to authenticate that, because now it has an SSL certificate, is basically it's going to generate what you call a pre-master. So it's going to come here and generate a pre-master key. Pre-master key. It's going to generate a pre-master key. Yeah. So after generating a pre-master key, this is just a random byte. Then in this pre-master key, what it's going to do is it's going to encrypt our pre-master key using our public key. Now we all know about public keys, and we know that here. So we have a public key that everybody can use. Public key is accessible to everybody. Yeah, so that's what we have. So we are going to encrypt. We're going to encrypt this using a public key. Pub key. So we're going to encrypt that. Now, why do we need to encrypt it? Because when we are generating the SSL certificate, when we're generating it, we have both private and public keys using what you call a Diffie-Hellman's key. And with a public key, in order to be able to encrypt it using a public key, you need to have an associated private key. So if I take this pre-master key and I encrypt it and then send it back to the server, then if the server can't decrypt it, then I know there is a problem, somebody has tampered with something. So after sending the pre-master key here, then the server now needs to decrypt it. So now server needs to, in this case, server is going to need to decrypt that particular key, pre-master. So it's going to come here and it's going to need to decrypt it, decrypt that particular key. Yeah, so if the key is decrypted and then it sends back and says, okay, the key has actually been decrypted. And then after that decryption is actually done, then what you're going to do is we are going to generate session key. Yeah, so session keys are going to be generated. So we're going to have session keys. So in this case, what is going to happen is we're going to have session keys generated. Session keys generated. So we're going to generate session keys. And how do we generate these session keys? Session keys are going to be generated by both client and server. These two TLS peers. They're going to be generated. How do we generate them? They're going to use three different things to generate them. So we're going to use number one, we're going to use client random. We're going to use client random and then server random, and then we're going to use a pre-master key. We're going to use. So if both of these particular end-to-end, client and server, are able to generate a session key using both client random, server random, and pre-master, then they should all arrive at one particular answer. If you don't arrive at one particular answer, then there's a problem. You terminate. If they arrive at the same answer, then now each of them can send a finish request. Okay, so each of them can now send a request and say, okay, so this client is going to say a finished request, and then in that case the particular server, the server can send back another finished, says, okay, session keys generated. And after that is now done, then now we can establish an actual TLS connection. And now we can establish a TLS connection. So TLS connection can now be established. Let's take this one here. Let's take this one up here, and then let's bring this. And then now we have a TLS connection. So our TLS handshake has happened, and now we have a TLS connection. And that is how. So now TLS connection makes sure now we are working on a secure network, and we are pretty much good. And now basically after now a TLS connection, now what is going to happen, depending on what request is. If you're typing google.com, you're going to have what you call a get request. You're getting, let's say you're getting the root, let's say google.com, the root file, and then it's sent. You get that request, and then the header comes back all the way to the browser. The browser will know how to render that, whether it's a HTML file, and that is basically a TLS handshake. So TLS handshake, we're basically done with the TLS handshake. I hope this was educative, and if you want to learn more, about this particular thing, then you need to visit things like you can just say TLS and then just say RFC, request for comments. Request for comments. This is where you find the real thing. You find the real thing, documents that are actually published by the original people the RFC documents, the original people that were actually writing about this particular standard. So it's super informative and something like that. Otherwise, hope to see you in another video. Thank you.